Welcome back, everybody. Welcome back to the channel. So I know I didn't do my typical usual Monday video. I was busy this weekend actually working on a feature that I think is worth the wait. Now, I'm not going to mention it in today's episode. We're going to be talking about something else, but it is something that I've been working on or trying to actually do for several months now, and I've recently just figured out how to do it. So it's going to be pretty insane. I don't want to get you guys' hopes up too much. I'm still in the testing phase. But from where things are looking now, it seems to have sped up the language actually just a little bit faster and offers some pretty massive gains in terms of actual usability of the language. So we'll see that later, but we're going to talk about today's episode, which is going to be how to compile or how to pre-process generic classes. So if I go back to the compile function, and if we go to post process, so now we're at a point where we need to pre-process the generic classes. So if you guys remember, whenever we pre-processed our classes, there was a potential that basically we could have created some generic classes when we were resolving our base classes. But at the time, we didn't know the full extent to all of the classes and how everything's inherited. So it wasn't a good idea to actually try to pre-process those generic classes. We're going to have this list of unprocessed classes. And what this is going to be is, again, this is going to be a list where things that we can't process immediately, but we need to process them at a later date in the future. These are going to be the list of classes that were created before any of this code ran that were not pre-processed at all or even post-processed. So what we're going to do is we're going to want to create a function called pre-process generic classes, and you want to pass in this unstable classes variable. And when you do that, I have this massive description here, so let's just read it. So there's a bit of a tug of war going on in order to how the actual compiler processes elements. In the pre-processing stage, we pre-process the base class of every single class in our code that we found, subclasses and all. This means that the time from pre-processing to now where we are could have we could have potentially prematurely tried to create a generic class due to it being used as a base class, which is again why I have that unstable classes variable. And then this requires us to basically protect and ensure that all the classes before post processing are created and were processed along with every other class. So doing this, however, also creates another conundrum where basically any classes created after the pre-processing will successfully pre-process themselves without me needing to hold their hand. Meaning that we can only do this dance for a select few classes and make sure during the pre-processing stage and every other class will either work itself out or be pre-processed or post-processed later. So basically what this is saying is kind of what I've explained before. So it's a bit of a weird situation. Now that we're at the pre-processing stage or post-processing, I don't know why I keep mixing up the words. Now that we're at this specific stage, anything created as a generic class after this point will pre-process themselves automatically. So that's why we have this weird stuff. So let's not keep rambling on. Let's just kind of keep going on. So what you want to do in this pre-process unprocessed class function is you want to say for the size of unstable classes, you want to say I is less than size, and then you want to just pull out every single unprocessed class from that actual list. And you want to retain what I call the primary class. Now, this is going to be one of these new variables that I actually just created like a couple weeks ago, which basically allows us to keep track of where we are in our compiler. Because I've had several bugs where we just don't know where things are. But what you want to do is you want to create a class object pointer called primary class. You can set this to null by default, and I actually think I'm doing it up here. Yeah, so I'm setting primary class to null by default. And what the primary class is going to represent is, so like, let's say if I go to, I don't know, the hash map in my programming language. So as we're pre-processing this generic class, once we get down to processing each individual field, we're going to have to keep track of the primary class or the actual parent class that we're inside of. That way, if we do something like, for instance, let's say, do I have something? Yeah, okay, so like entry.next. Here's an example. So the way that my compiler works is it works on a dot notation or a current scope basis, which is kind of a weird way to say it. But basically, when you access the entry field is going to be this entry class here. And when you say entry.next, well, now the current class that we're pointing to is now going to be the entry class, and it is no longer pointing to the hash map. So if in here in the entry class, as we're assigning this to next, we want to assign this data field inside of this class, well, if we think that we're inside of the entry class, then that could obviously pose a problem. So if we try to locate a field, we're going to try to locate it from the primary class, which is hashmap, to pull this field down. I know that's probably a bad way of explaining it, and there's a lot of weird stuff in this compiler that I'm really going to struggle with, but hopefully you guys understood that. So create that field, and in this retain primary class, all you do is just save the old value of the primary class, and then you set the primary class to its new value. And then to restore it, you set the primary class to the old value. I have a bunch of these retain and restore define statements here, which basically just retain and restore information or states in the actual compiler to make my life a lot easier. So that way I can basically change the state without ever having to worry about messing anything up, basically. So it's a really nice way how I kind of manage state in the compiler. So once you do that, then you want to set the current module equal to the unprocessed class's module. That's going to be the module pointer inside of the data entity of that actual class object. And once you do that, then you want to get the current parser. Now, when it comes to pre-processing this class, right, this file is going to be in a completely separate file. Like all these pre-processed classes that we're going through, like, let's say we had a size of, I don't know, 10 classes, right? So if we have 10 classes, it's pretty safe to assume that not all 10 of these classes may or may not be in the same file. So this is where we're getting into a concept, what I call dynamic compilation, which is basically you can compile several different things that are existing in different spaces in different places in the code space, and you can point to the exact error. Like if there was something wrong with this size field as we were pre-processing it, we want to say the size field in here. We don't want to say, like, for instance, in here, where if I created this entry and I created this entry of this type, you don't want to get the error here complaining about a field that's inside of this entry class. You want to actually get the error down here and say that, this next field, there was something wrong with it. So basically, the way that I do that is I get the parser by the source file. So I access the unprocessed class, I get the generic owner, and then I access the metadata of that generic owner. Now, the reason why I access the generic owner's metadata and not the metadata from the unprocessed class, because the metadata from the unprocessed class is going to be based on where that class was created. And this is very important because you do want this to be the case, because if you get any errors, I'm actually looking, yeah, here it is. So if you get any errors, you want to say, all right, I got the error encountered here at this line when you created this class, and then also subsequently give them the actual error of inside that class what the compiler found that broke. So for instance, if this next field could not be a specific type, then we'll get the error here, and then we'll also get the error here as well, so that the user knows where to fix the actual error. So that's why we do that. The generic owner's metadata is going to be based on the point at which the generic class was found at. So if I go back here, once you do that, you want to access the file, get the name, and then to get the parser by the source file, it's really simple. You just for loop through the name or for loop through the parsers, and you just compare the parser's tokenizer, access the file, and check to see if that's equal to the name. And if so, you return that parser. Otherwise, you return null. Now, there's a high chance that if you pass the source file, you're going to get the parser. You're not going to get null here unless you have a bug in your compiler. But yeah, so keep that in mind. And then I just set the current parser to that. And then I I save the total errors for checking later on, and by getting the unfiltered count. And then I update the error management system from the actual current parser that we're at. So this is going to update all the necessary things so that we can get the appropriate errors. So if I go back, so once we do that, and I've already gone over this function, so you should already have this in there. And it's pretty simple, guys. So what I do to pre-process a generic class is first I set the processing stage. So I have a concept of processing stages, and this allows me to basically, and this is only used for generic classes, by the way, this allows me to kind of know where I am in the stage of processing a generic class. Because otherwise, you may or may not want to do certain things, if it's at a certain stage. So that's what I use this for. And what I do is I set it to pre-processed. This is a function here, and I created this generic processing stage field. inside of the class object that I created a while ago, that I showed you guys a while ago. So not sure if I went over that field. So again, there's a lot of code that I'm going to have to show you guys. So I apologize if I'm reviewing stuff over. But after that, you want to pre-process the class declaration. And here's where it gets into the interesting part. So you want to pass it the AST of that unprocessed class. That's going to be the exact AST at which the parser actually, I'm going to close these files because I keep clicking on them. That's going to be the actual AST where the parser encountered this actual class. So we can basically just process it as if we were processing it for the first time. So we pass it that, and then we pass it whether or not it's an interface. So we check to see if the class is an interface by getting the class type, and then of course we, do our little bit shifting here for the interface bit. And I think interface is the value of 3, I believe. I don't remember. Oh, it's 1. Okay, so yeah, I just basically do a bit shift to see if this bit is enabled. If so, then great. So once I do that, then I also pass it the unprocessed class. Now, this is the interesting part. So if I go to preprocessed class declaration, this exact function is the exact same function that I was using and that I showed you guys when we went over how to preprocess classes at the very beginning a while back. So before we started getting into the virtual machine and everything, if you guys remember, you passed in a current class and we checked to see if that was equal to null. And if it was, we, did whatever. Otherwise, then we said, generic class equal to true, because obviously we're pre-processing a generic class. And then we just did everything in here. So we're literally just calling back into that exact same function. It makes it a lot easier to, manage code and stuff. After you do that, you want to resolve the superclasses for that generic class. So now that we're basically at a point to where we know all of the classes that we're ever going to encounter in the source code, and we also know everything those classes are inheriting, it's pretty safe for us to resolve the superclass of our generic class. So we want to do that. And then finally, we have two helper functions. So these two helper functions are going to be used for our system to normalize things, basically. So if I go here to syntax, let's say I create an enum of, I don't know, number, or no, that's a bad one, color. So if I say an enum of color, and then I give it a color of, I don't know, red, green, and whatever. I'm not going to write all of them, but you guys get the point. Basically, if you guys remember, this is translated by the compiler into class color base underscore enum. And this allows us to then, and then it has like a, what is it, public static constant red, and is equal to new new of, and then we pass it the ordinal. So the compiler is going to generate, if the user doesn't pass the static value here for the enum, the compiler is going to generate something. So let's say like 100, and then the compiler is also going to generate a public color, and then ordinal, ordinal, and that's going to be a var. And once we do that, then we can call into the base function, or actually here, I'll do this. So I remove this. And if you guys didn't know, this is the syntax for calling into base functions. You basically just say arrow base, and then you can pass it the ordinal. So ordinal, and that's it. So this right here is basically translated into this. So we're going to see the first part of this translation, which is inheriting the enum as the base class. So that way this can be fully supported by our programming language. So if you want any enums to have all of these functions here, then you can do that. So the way that I do that is for the enum class helper, let me go back. So I pass it the AST of the unprocessed class, and then the unprocessed class itself. And then in here, I do a couple of checks. So first, the class obviously has to be an enum. So I check the appropriate bit to see if, the enum, or if the class is in fact an enum class. If so, then I want to get the base class that we're going to be inheriting on there. So what I do is I say base, and I try to find a class, and I pass it the module of std, and then underscore enum, and then I pass it the classes list. Now, because we know that we're kind of at the post-processing stage, this is completely safe to do. So I get the base class, and then I check to see if the base is not equal to null, and if the class is an enum. So I do checks, like if the user goes in here and tries to manipulate this standard library, which by the way, guys, I don't recommend you try to go into the standard library and switch things around because a lot of this stuff is used by the compiler directly. There's a lot of stuff in here that the compiler directly interfaces with, and there are checks for that, so you will get errors if you do modify things, but it's just not a good idea. If you want to modify stuff, and sorry I'm getting off topic, but let's say you wanted to modify the enum class, you'd create a define underscore enum, and you'd use what's called an extension function, and you can say, I don't know, do work, and you can, create this extension function, and you can do stuff in there, and then later on, let's say you have, this foo function, and you access, the red enum that I created, you can say red dot, and then do underscore work. And you can call that function as if that function was always in this class. But anyway, let's get back to the actual video. So if I go back here and here at enum, so once we get this class, then we want to check to see if the physical class is in fact an enum class, or if it's an interface, or if it's a generic class. If it's any of those, that's obviously problematic. So we want to say support class for enums must be of type class. So if the user changes to like a generic class or whatever, you don't want them doing that. And then finally, what I do is if the base is not equal to null, so obviously if it's none of these, if it's just a regular class, I check to see if the base is not equal to null. If so, I set that as a super class, which literally just sets the super field in the class object. After that, then I say support class for enums is not found. So if base is equal to null, then that obviously means that I couldn't find the class. So that's how I pretty much inherit enums. So now let's look at object. So we've basically already seen how I converted this to this. Now we need to see how I convert this enum class underscore enum, to a base of object. So I actually need to do underscores as well. So how do I inherit objects on every single class? I know some of you guys have worked with Java before, and Java does this where every class is an object. So let's see how we do that. So basically, in order to do that, again, it's very simple. You just pass it the AST and then the class or whatever. We're also going to use this for regular classes as well, so don't worry, this is not a generic only thing. I'm just going over the code for generic classes for now. So you pass in that stuff, and then you check to see if the class name is not equal to object. I actually ran into some pretty wild bugs because of this. You do not want the standard object class to inherit standard object. That is a nightmare. Just trust me on that. So don't do that. You also want to make sure that the actual class does not have a superclass. The reason being is because if I go here, so let's say I create like a normal class called foo. If I have a base of foo2, obviously I don't want to override the superclass. So I'm only going to basically set classes that do not have a superclass to derive object, object, the object class as, a base class. So that way, if I go back to the example of foo2, then we would basically have a hierarchy of foo2 and base of objects. And that's basically how it's supposed to be. So that way you have a proper hierarchy when you're accessing your information. So let me go back. So if I go to inherit object, so once we do that check, then we want to obviously get the class or the base class that we want to inherit. It's the same way, you just get standard, the standard module, and then the object and pass it classes, and you do the same checks here. It can't be null, it can't be an enum, it can't be an interface, and it can't be a generic class. If it's either of those, we complain saying support class for objects must be of type class. Otherwise, if it's none of those and it's just a regular class, we want to make sure that the base is not equal to null. Now I have another caveat. So the other caveat is, if you guys remember, every class that's created at the global scope is considered classes that derive the, class underscore SRT global class, right? So any classes that are created at the global scope are basically child classes of the SRT global. But the SRT global technically is not an object class, so we don't want the SRT global class to have a base of object because that just doesn't make any sense. So we only want the subclasses inside of the global class to be objects. So in order to curtail that, I basically, why does it, oh, it's in this one, okay. Basically what I do is I check to see if the full name of the class does not end with hashtag global class, and global class is SRT global. And the reason why I do ends with is because if you guys remember, we can have, std hashtag SRT global, we can have std.io. Basically, for every package that's created, we create a new SRT global class in that package. So you want to just make sure that the hashtag part, regardless of what package it's in, is excluded from inheriting the object class. Once we go through all of those hoops, then we can finally set the superclass of the class. Otherwise, if the base is equal to null, then we say support class for objects not found, and it's just a generic error. And that's it. So once we do all of that, now we're ready for more advanced stuff. So I'm not going to go over this stuff today, but I will say definitely create these functions. So the first function is going to be called resolve class methods. This is going to be actually the next thing I think we're going to go over. It's probably going to be the next episode. But basically, this allows us to resolve all methods or functions in our programming language. So for that, all you need is to pass in the AST and the current class that we're in. And the other function you want to create is resolve unprocessed class mutations. So you want to do that as well. That's going to take a class object of unprocessed classes, and that's pretty much it. And both these functions return void, by the way. And that's it. So once you create those two, we will come back to those functions, trust me, later on. We just got to go over a lot more stuff before any of this makes sense. Finally, once you do all of that, so you probably won't have this code here for now. You can either comment it out or whatever. Then you want to check to see if we have any new errors. If so, add this current parser that we're processing to the failed parsers. And then after that, we just restore the primary class that we were processing, and that's it. And I do it at the end because obviously if we hit the last element in the list, we want to revert back to the original primary class, even though in this case it's probably going to be null, but it's just formality. So once you do all of that, that's pretty much it. We've pretty much gone over how to pre-process generic classes. So it's pretty simple. Hopefully I explained this pretty good for you guys. If you have any questions, as always, put them in the comment section below. And like I said, the next video, we're going to be going over how to compile methods. So that's going to be Wednesday. That's going to be tomorrow, basically, for you guys, because I'm publishing this video on Tuesday. And yeah, so hope you guys enjoyed the video. As usual, if you would love to help support the channel, you can always head over to the GitHub repository at andrewdevcd/sharp. And when you do, definitely watch, star, and fork this repository. That gives this language a lot more visibility and let other developers know this language exists. Also, if you guys are curious about some of the stuff that I'm looking to add in the future to the language or stuff that I'm working on currently, you can head over to the roadmap section in the projects tab. And in there, I write a pretty decent description of, some of the stuff that I'm working on in real time. Definitely recommend checking it out. It is kind of interesting to see what I'm up to. I actually need to update this as well. It's kind of outdated. But yeah, so that's going to be it for today, guys. Of course, if you guys are new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.